Right then. Well, let me introduce you. Welcome, one and all. The skills and learning stream this year has been very very fortunate to get our hands on some very distinguished speakers, and Reg Harbeck, who's here with us today, is indeed one of them. I was going to say an IBM champion for how long now, Reg?
I think it's 5 years, but I haven't got my 5 year pin yet, so I'm not certain if it's only 4 years or 5 years. I started in 2020.
2020, and I believe in terms of Z champions in the Canada region, I think that there's very few of you.
Yeah, so we fortunately now have more than one IBM Z champion in Canada, but I was the first.
He was the very first. So this is a man who knows a very great deal about the platform that we're all interested in, and today he's going to share some of his knowledge with us. So before I let him loose, um, at the end, if you could follow the link to the feedback. Um, uh, through the bring your own device, and it will kind of it'll put up your badge number and give you a chance to kind of give Reg some feedback on what he's had to say. But I'm going to get right out of his way. There'll be time for questions at the end, but if there's something that you absolutely positively want to know, do stick it in the chat and I can let Reg know. Okay, so Reg, I shall get out of your way, and thank you so much.
Thank you, Herb. So let's get started. um, I'm Red Charvick. I've been working on the mainframe platform since 1987. Actually, I was born the same year as the mainframe was announced, and so it's been part of my life and my journey. Recently I got a Master of Arts degree in interdisciplinary humanities, which is philosophy, English, and history. But I really tried to focus on the humanity of the mainframe, and that's really been a key topic for me over the past few years. But my background, I started out as a CICS or KICS systems programmer. Being based in Canada, I speak like a Commonwealth person a little bit more than the folks south of us do. So I am prone to say Z, but I've also been trained to say Z. So you'll get both of those out of me today. So what I'm going to talk about is basically the people of the mainframe. And the thing is that the people of the mainframe, are multiple generations. Here we have this one mainframe, and it's easy sometimes to forget just how persistent a fact of life the mainframe has been since 1964. And again, for myself, it's been a fact of life since I was born. Um, but that the people have continued to come and go in multiple generations. And for that matter, there's all of the generations of humanity before the mainframe. Now, when I was putting together this presentation originally, the second point of the slide said pre-mainframe. And so I copied and pasted pre-system 360 instead. You can see you got space in there accidentally because, well, of course, space is always that final frontier. But I realized that I need to make that distinction because, of course, there were mainframes before System 360. So I'm going to talk about the people, the culture, the humanity, all of that that led up to the System 360 mainframe, and who were the people that really made that what it was over the coming decades, and what are some of the cultural and other factors that really shaped the people who became the people of the mainframe over the subsequent 60-ish years, and then take a look at where we are today, and who are the people now that on the one hand are keeping the mainframe alive and well, but on the other hand are inheriting the mainframe and moving it forward, and what is the mainframe that they're moving forward. So let's start with the proto culture of the mainframe. Now, one of the things that I found in my degree as I went to study about the history of humanity is that the culture of the mainframe already existed at the time of Socrates. And you see his various dialogues, and he talks about the idea of poesis and techne, of art and craft, and just how we design things, and what that is as a manifestation of our humanity. And by then, we already had business happening. We had money happening. We had people doing transactions. And all of the things that were happening back at the time of Socrates for the subsequent 2 millennia, and for much time before then, were really the things that humanity was fine-tuning and building and taking for granted that made us humanity from a business and related perspective. At the same time, we continue to advance in other areas, including fiction. So on the one hand, we have the accounting principles. We have the idea of double entry ledgers, the balances, the tallying of things. But we have ideas of what if we created something that was intelligent. And so, Mary Shelley's Frankenstein's monster is one example. But again, you can go way back in history to us asking questions about that. What if we automated in a way that created some sort of intelligence? So we have those threads, and then we have just the day-to-day drudge work of doing hand computing. And so we would create tables for things like ballistics in order to fire guns properly. We had logarithms for doing advanced calculations, things like slide rules, of course, and other kinds of heuristics in order to really do stuff pre-computing or pre-electronic computing that still needed to be done. And we have people who are part of that journey of helping us move forward with sort of an implicit aspiration of finding an automated way of doing all this. So on the one hand, we have Jacquard, who created his loom, his automated loom that was driven by punch cards back in 1800. And then the mid 1800s, we have Babbage and his analytical engine. And, even though it was never created, it was theoretical, yet it still had a role of showing what punch cards be used for. And then Hollerith, who showed in real practice that punch cards could be used for tallying the US Census. And based on that, he founded a company that ended up being merged with two other companies to create the Computing Tabulating Recording Company, which eventually was renamed to IBM. And so all of these different factors led into all of the coming together of stuff that happened after World War II. But meanwhile, World War One, World War II happened. Punch cards started to predominate in how we process data, and the World War II ended, and the world started to refocus and look at what could be the future. And one of the things that happened was that there's a whole bunch of punch card machines, which during World War II amounted to the closest thing to computing that was generally available, in imitation game notwithstanding. That allowed doing data processing. And IBM liked to lease these things. They got them all back from the war effort. And they had all of these available. And so everything was ready at the end of World War II for us to start moving forward with all of these things we've done throughout the history of humanity. Um, so then we see the beginning of modern electronic computing happening right at the cusp of the end of World War II and for the next 20 years. And so you see things like this excellent movie, Hidden Figures. We see the people who both were computers and helped creating modern computing in their roles right at the front line of what it meant to be computing and to be a computer. At the same time, we also see the aspirations that were continuing to be built and fed in humanity. What would a computer be? What would it do? Is it the same as a robot? Is it distinct from the robot? So we see in the movie Forbidden Planet, for example, where there's a planetary computer that's processing people's desires and trying to give them everything that they want, and the discovery that what people want isn't always in their best interests. And so all of these things fed into the same thinking that was also being grown in the meantime. And so rewinding a little bit to the mid 1800s, we see on the one hand Lord Lovelace, who was documented as having theorized that they needed some way to take all the mechanizing that was implicit in the then Industrial Revolution and remove the people from it because they were so unreliable and find a way to do it truly automated. And meanwhile, his wife, Lady Ada Lovelace, was in touch with Charles Babbage, who had theorized to the point of being nearly executable these analytical and other engines. And she actually wrote what may be one of the first computer programs for a platform that didn't even exist yet to compute Bernoulli numbers. And so there's this whole discussion about what computing could be, meant what you could do with it. And that whole discussion continued on right to even just before World War II, when we see Alan Turing, again, who was memorialized in places such as the Imitation Game, coming up with some of the original theory of computing and describing what a computer was, what it could do, among other things, with his Turing machine, which is basically a string of characters and a set of rules and a cursor, and all kinds of theory that could be based on that until the realization that any computer could do the same thing that any other computer could do, give or take qualities of service. Um, And so then, given that, we have the arrival at the end of World War II of practice. And one of the first real contributors to the practice of modern computing was Thomas J. Watson Sr., the IBM, the definitive leader of IBM for decades, really turned IBM into the great company that it became, and who was right there at the birth of computing. You know, it's interesting that Watson is claimed to have said that there may be a worldwide market for maybe 5 computers. And if that was the case, certainly that was sufficient for them to build the whole history of computing, because the fact that those 5 computers were so significant. But probably he didn't say that. What he did say was, just don't make it the International Busa Machines Company. Well, he said that to Father Dr. Jesuit Roberto Busa. Now, Busa was an Italian Jesuit who happened to stop by the IBM offices in Manhattan and say, you know, I understand you got some surplus punch card machines. I have a lifelong project of creating an index an index of the works of Thomas Aquinas, a lemmatized index, which means it's not just a character search, because lemmatized means you're indexed based on the root word, even if it declines or conjugates to different words in Latin. And so he says, but the problem is that I would like to use automation, but your punch card machines only take numbers, but punch cards could actually handle letters as well. And so we were wondering if you could adapt some of your punch card machines to do letters as well as numbers. And Watson said, well, you know, I was talking to my people about this because we knew you were coming. And they said that this is going to be really hard. And Booster brings out this little punch card shaped advertisement that had been in the waiting room, and it says, IBM, the difficult we do right away, the impossible takes a little bit longer. And so Watson laughs and says, okay, just don't make it the International Busa Machines Company. And so they adapted the machines, and Busa started doing this stuff. And that's kind of cool, because that, among other things, created the direct lineage between Thomas Aquinas and XML. And I've written articles about it if you want to Google them up. But it also meant that now character processing was part of computing just at the dawn of computing, when the punch card machines were slowly becoming an aspect of this nascent field of computing. And that was in 1949, I think. And within a couple of years, Grace Hopper, who eventually was Dr. Rear Admiral Grace Hopper, was coming up with the idea of a compiler, which again meant computers were so much more than just glorified calculators. And so over the next decade, in the 1950s, we see all of these things being innovated as the baby boom is kicked off, as culture recovers from World War II, and all of the stuff that happened at those times. And meanwhile, as we continue to investigate and see what computing could be, we have the theorizers and the designers. So we have the von Neumann architecture, that everything can be in memory, including programs. We have Dr. Fred Brooks, who was then drafted to lead the creation of the System 360 and OS360, to Eugene Amdahl, who was really the execution man that made it happen. And so we see on April 7th, 1964, the arrival of IBM's System 360, which was really the manifestation of all of the lessons that had been learned about computing to that point over the past 20 years. And we have a whole bunch of different models of computers that led up to that. And so some of the key constituents, the people, the organizations, the cultures that were there at the birth of System 360, that the wheel of computing, the 360 degrees of computing, if you will, were the customers of IBM's previous computers, who discovered that if they wanted to move forward, they had one more hardware platform they had to rewrite everything for. But you've also got the space race, because by the time System 360 arrived, the US had already been on the journey of getting to the moon for a few years. And the mainframe was part of that effort in a lot of ways. And then we have the creation of the mainframe itself, the physical hardware, that was a manifestation of all of the bureaucratic things that we needed to automate, and all of the other things that we felt we could automate using computing. And so you have Dr. Fred Brooks describing the System 360 hardware as a Platonic ideal, a manifestation of exactly the ideas that they were trying to achieve. But that said, that same Dr. Fred Brooks spent the rest of his career apologizing for JCL. JCL, job control language, being, of course, that wonderful thing that allows us to write such interesting and obscure things that become the jobs of the ages, because they work so well. Because part of the issue is that at this moment in history, with System 360, we went from having to rewrite programs every time a new hardware or language or anything came out, to being able to write it once and then not change it again until there was a need to improve something. So on the one hand, in the 1960s and 70s, we see the age of the big operating systems. You see OS 360, but also things such as Multics and VMS. And we see the arrival of that concept of permanence. And part of the arrival of that concept was the experiences of creating the permanent circumstances, such as OS 360, which led to both Fred Brooks' first book, The Mythical Man Month, and his law that adding programmers to a late project will make it later. But we also see COBOL, which, again, Rear Admiral Dr. Grace Hopper had been involved in creating. That meant that you could now write a program once and not have to keep rewriting it for new architectures. And System 360 that said now you could write a program once and it would run on all of the different System 360 and subsequent computers. And so that we have that today, there are still probably programs written in the 1960s that are running on computers today, and certainly programs written since then that haven't needed to be modified and so are still active or modified slightly inactive, but not completely rewritten. So meanwhile, the key constituents of System 360 are the organizations that run the world economy. And these are the financial organizations, the manufacturing organizations, the government, and so on. That these are the organizations that really went all in on System 360, particularly as it became the one thing that really clearly worked. And as all the various competitors to it kind of fell by the wayside because it worked so well. And it was kind of like, getting a fax machine. Everybody else gets a fax machine. Now you're all part of the same thing. And so all these organizations shifted the world economy onto the mainframe, which essentially, with complete integrity, automated what they were already doing properly. This is important. Bill Gates famously said, automating an inefficient algorithm will not make it efficient. The other side of that coin is that automating something that already works will allow it to keep working only better. And that's what System 360 was designed to do. But it was designed to do with the sensibilities of the old school people who, measure twice, count once, were very aware of all the limitations of the real world and took that awareness to their approach to the mainframe. Now, many of those people got together in, for example, user groups. And so we have Share being founded in 1955 and giving input to the to IBM as they were building System 360. We have Guide, which was founded shortly thereafter, and GSE, Guide Share Europe, and its constituents, and a bunch of other organizations that were founded over the years continue to give input to IBM as they advanced the mainframe technology and first of all developed it, and really were the key parts of the mainframe ecosystem and culture that formed. And so one of the things I want to point out from that is the mainframe culture and ecosystem predate the mainframe. And that's important because it's really the only widely used platform that that's true of. Every other computing platform, which I often refer to as being consumer electronics, commodity computers, had a culture that mostly accrued around them or was not a culture about them, but the mainframe culture existed as a culture to create and work with the mainframe, but as a manifestation of all the organizations and users of that mainframe before the mainframe came out, and they became the people who built the mainframe culture. And so we see, as I'll refer to soon, some of the many ways that that pre-computing culture manifested itself in the arrival of the mainframe culture. And part of that is that each of the organizations that had mainframes eventually had their own very unique cultures. And those of us who've been to multiple mainframe shops can attest to the fact that each mainframe shop has very much its own personality in ways that sometimes are great variants from the theory of System 360 and successors. And who are the organizations that really became the key keepers of the mainframe ecosystem and culture? Well, they certainly include governments, military, academia, healthcare, finance, manufacturing, retail, airlines, hotels, punch card users, organizations that originally used punch card and moved to using computers and often used punch cards for input to those computers for so long that the echo of the punch card is still prevalent in the way the mainframe does things, including the fact that so much of the text on the mainframe is 80 columns wide. Now, one of the other interesting threads into the mainframe culture and ecosystem was some really interesting and eccentric behaviors by the members of that ecosystem, beginning with the very core member, the Saturn around whose rings are the ecosystem, if you will, IBM. And so if you take a look, the dedication and loyalty that IBM employees had is manifested through songs such as the songs of the IBM. We see a 1931 example of the IBM songbook, and then on the right we see an example of the Cher songbook. Now, I would tell you something that very few people seem to know, that I am now the official keeper of the Cher songbook. I was given that by Helen Sarin, who had been the previous keeper of the Cher songbook nearly 20 years ago. But we have kind of backed off from singing at Cher, and there's room to discuss whether or not that needs to continue the case. But in any case, just this eccentric practice of singing at the skids, or the last evening of Cher, and other opportunities for excess, which are not always extra small, really are ways that we have sort of lived out and demonstrated that culture, manifested that culture in the world of mainframe. And of course, one of the advantages that we had singing, because the songs in the songbooks, the tunes are almost invariably tunes everybody already knew, and we just rewrote words to them. And before the internet and before companies started claiming every song or piece of music you play, we could do that. But I know one of the songs that I contributed to the Cher songbook, I asked my friend uh, Jim Michael to sing and play it, and I published it during COVID on a tweet and a few other places. And even though he sang it and played it, because it was a well-known tune, the various keepers of copyrights on the internet came and claimed our video and wouldn't let us publish it because of the fact that it was a Beatles tune that we used for that song. And so on the one hand, we have these earlier, more forgiving days in some ways, but on the other hand, we had the jet dress codes that were so consistent with the IBM image, the white shirt and the black suit and tie and all these things, that we were buttoned down in some ways, even though easygoing in other ways we didn't even realize. And couple of the ways that we were easygoing that we didn't realize was treating everything but the physical mainframe hardware as just add-ons that are included in the price. And so there was this slow realization that things such as software could actually be separate businesses, could be something that had a separate business value. And more to the point, that the mainframe was so successful with IBM leasing just a result that included hardware and services and software, that there was a concern that it was impossible to compete with IBM. And so, in order to avoid the implications of that, IBM had to unbundle their various things, the software, the hardware, the services in the 1970s, so that there was room for competition. Now, here's the thing. Once the mainframe opened up to some really serious competition in things such as software, a number of other things happened at the same time. But what that meant, of course, Cher was still, alive and well and going strong. For example, it had been around since 1955, and so by 1975, there were independent software vendors in the world of mainframe. But just because they existed, it didn't mean they were welcome in places such as Cher, because there's sort of this feeling that people who came along and competed with IBM were questionable, whether it was Amdahl or other makers of the hardware, whether it was makers of software, treated a little bit like rogues. And yet they were inevitable parts of the mainframe. But they weren't the only constituents. One of the things that was another constituent on the mainframe that actually goes way back before the mainframe is shared software or shareware. In fact, if you go back to 1960, there's something called SOS, which is the Cher operating system, which is an operating system created by the Cher user group that existed for pre-mainframe architectures. Other things that were happening between the 1960s and 70s include things such as time sharing. The original System 360 machine had the aspiration of being able to slice up and give time to more than one user at a time, but it wasn't fully manifested until basically end of the 60s, early 70s. And virtualization, which was nascent during the 60s, really kicked off during the 70s, and everything from putting a V into the name of everything they possibly could to show that it was virtualized, whether it was VTAM or VSAM or MVS, that V is virtual all the way across the board, or VM, but boy, VM was virtual. 1972 when the original hypervisor came along. But meanwhile, there's other sharing, and there's the CBT tape that came along, the Connecticut Bank and Trust tape, which is basically another community initiative to share software, which was the idea behind Cher, was the idea behind the CBT tape, and the idea right in the middle of this whole mainframe culture that we sometimes forget, because one of the things that's most powerful about the mainframe culture is being a small community. It really is a community. And so people work together, they talk together, they discussed and found things that needed to be dealt with. For example, things such as security. And so we see Barry Schrager and his colleagues coming up with the original principles for computing security, which led, among other things, to the development of ACF2, the enhancement of RACF, the creation of Top Secret, and all these other things that really moved computing forward. And the demand for all these features, the advancements on the mainframe, became a key part of what the community and especially through the user groups offered. And part of that was realizing that although in the 1960s, maybe megabyte or two on the mainframe was enough, and even if in the 1980s, Bill Gates said 64K ought to be enough for anybody, or was it 640K? Either way, the fact is that by the time that the 1970s came around, 16 megabytes was starting to feel really cramped, and the culture that had predated the mainframe was already one of frugality. But also, we had some interesting other things on the culture, and I referred to JCL. One of the funny things about JCL is it had 6 verbs, and those 6 verbs had to do everything. In order to do that, you had to do some spit and glue ways of doing things. And one of them was you could not run a job step unless it had a program to run, even if JCL was doing all the work. And so the wonderful program, my favorite program, was invented, IEFBR14. I love this program so much. I wrote a haiku rather about it. And as you can see on the screen, it goes like this. Hero is 0, IEFBR 14, strength from far niente. Now, I'll admit I have poetic sensibilities. I'm not going to say I'm a good poet, but it doesn't keep me from trying. And so about 5 years ago, I came up with something that really was intended to be sort of a manifestation of a certain perspective on the mainframe, recognizing that it's also sort of a snapshot in time because it's already out of date in some ways, but in other ways will always be irrelevant. So let me read you my mainframe ABCs. A is for a bend, which is a break that causes pain. B is for BCP, what makes the frame go main. C is for COBOL under kicks that run so well. D is for datasets where mainframe files do dwell. E is for EBCDIC, a coded code to log. F is for Fox, an Able Baker's easy dog. G is for GDG, a sequenced set of files. H is for Halasm, Dr. Ehrman's source of smiles. I is for IPL to make a mainframe boot. J is for JCL, a workload scripting root. K is for keys to storage, more than simply 8. L is for Linux, keeping endless penguins straight. M is for MVS, now known as ZOS. N is IEFBR14's role, nothing less. O is for OSA, brought the mainframe to the net. P is for PTFs, we hope we won't regret. Q is for Qs and MQ series, JQs, more. R is for Rex, the Rascal language we adore. S is for SMF that tracks the mainframe's work. T is for TSOE, where the sysprogs lurk. U is for USS, an enterprise platform. V is VM's virtual recursion to the norm. W is for WTOR, which Miss will vex. X is for XCF, to couple to a plex. Y is for Y2K, which proved we're mean and clean. Z is for System Z, the ultimate machine. Now, I want to go back and just take a look at quickly a couple things here. And one of those XCF, we've gone on and on about how this is the 60th anniversary of the mainframe. It happens to also be the 30th anniversary of the parallel sysplex, which really turned a single mainframe into multiple mainframes into a single mainframe in so many powerful ways. But I'm also going to go back to F, Fox, because that one seems rather obscure unless you get the reference. The reference is that the mainframe culture, again, was formed by people who never worked on a mainframe because they predated the mainframe. Many of these people cut their teeth in World War II and subsequent to that. And one of the things that was the case is that back then there was a completely different set of phonetic words for the alphabet. Now, I found this out the hard way in my career because I went to work on a mainframe in '87, and I knew what the standard words I was talking hexadecimal on the phone were, and that was Alpha Bravo Charlie Delta Echo Foxtrot. We all know that. And I could not figure out why my mainframe colleagues were using the wrong words. And I tried to make fun with my own set of wrong words, and it didn't play. And it took me decades later, as I went around the world and met with people mainframes around the world to realize that experienced mainframers, especially of a certain age and above, all use the same wrong words. And finally looked into it and discovered those were the words in World War II for the letters A through F. Able, Baker, Charlie, Dog, Easy, Fox. That's one of the cute little secret parts, secret handshakes of the mainframe culture. So if you're talking to an experienced mainframer and you're talking EBCDIC, or sorry, if you're talking, yeah, EBCDIC or anything else in hexadecimal, and you use those words instead, that's a little bit of a shibboleth. That is a special insider word that tells people you're part of the inside, just like saying DASD. So moving right along, the times they have been a changing since all of this. And so we take a look at what has happened over the past, well, 60 years. That the culture's changed, the technology has changed. Look back at things such as security and Barry Schrager and the arrival of the uh, idea of security, but also the arrival of the idea of integrity. Because when Barry put together a list of security requirements back in the early 70s, IBM looked at it and they said two things. They said yes and soon. And the yes was there are some things in that set of requirements that had to happen right away and should be part of the operating system. And they turned that into the system or the statement of integrity, which has continued to be part of the Premier Mainframe operating system ever since. And so you can Google up IBM statement of integrity and see that basically what it means is that you can't do anything on the mainframe you haven't explicitly given it configuration permission to do. And they stand behind that. And then above and beyond that, then they have ACF2 RACF top secret external security managers that allow you to then manage and configure the policy of the security. And so that whole journey of security, which among other things includes the arrival of some interesting wildcard characters. If you're ever interested, I give a presentation called a Mainframe Security Rosetta Stone, where I just talk about the three systems. Now, other things happen. One of them is the growth of the memory. So the original mainframe had 24 bits of addressability in 3 bytes. Even though it used 4 bytes for the register, it uses for addressing just 3 bytes. Interestingly, if you look at the IBM logo since for most of the time since then, it has been IBM, each with 8 bars in it. And if each of those bars were a bit, then the IBM logo implicitly represents the 24-bit addressability of the original mainframe. But that only gave 16 megabytes of elbow room, and that wasn't enough. And so by the 1980s, people were just bursting at the seams, and IBM came along with the XA architecture, 31-bit, because that 32nd bit was there to keep compatibility as people could move back and forth between the old mode and the new mode and have that much larger addressability, the whole 2 gigabyte space. And then within another couple of decades, that wasn't enough. So by the turn of the millennium, the mainframe stretched way out to 64 bits. And in theory, with I think it's 16 petabytes, that should be enough, but we'll see. Then the journey of TCP/IP. Now, TCP/IP arrived in the non-mainframe world, the computing world, around the late 60s and continued to be developed concurrent with Unix. And so we see that all of the various descriptions of how TCP/IP works are very much done the same way that Unix is described, as the two of them grew up together, so that by the 1990s, they had become sort of de facto standards for a lot of what people did off the mainframe. And so the mainframe then adapted to that. And for a lot of reasons, including various requirements that any production computing platform have these features, the mainframe introduced, first of all, as Open Edition, and then USS, the ability to have Unix system services and TCP/IP, so the mainframe is no longer an island, but was in fact part of the whole world of computing. And so people who did TCP/IP and Unix were able to interact with the mainframe. And then meanwhile, we have Linus Torvalds come along in the, I think, late 80s with his Linux. And that being a Unix was written in C or Unix-like, and therefore could be recompiled anywhere. And so a young IBMer recompiled it for the mainframe hardware. It was so successful that by the turn of the millennium, we had Linux on the mainframe, and we had hundreds of thousands of Linuxes on a single box with VM, or now ZVM, as a hypervisor. And so we see the turn of the millennium and Y2K and all these other things happening, and the dawning awareness, first of all, that the mainframe was not going to go away. Stuart Alsop's prediction in 1991 notwithstanding, when he said that by March 15th, 1996, the last IBM mainframe would be turned off. We see in the right-hand corner a picture of him eating his words when that turned out not to be the case. And so by 2005, it was pretty clear that the mainframe not only survived Y2K, but it was going to survive a long, long time into the future. And it was necessary to start thinking that way and planning for the future. In 2004, in my role at a large software company, in charge of the global mainframe services strategy, I wrote a white paper about the need to get a new generation on the mainframe and spend the next 20 years going around talking about that. It's been 20 years since I wrote that white paper, and a lot has happened about that, including the founding of ZNextGen in 2005. So that's 19 years ago today that the project at the Share conference was founded in order to bring new generation on time. You could see that all kinds of ways new generation people are now active, and obviously not just at Share, GSE is doing all kinds of cool stuff. And so then we see IBM, of course, also doing all kinds of cool stuff. On the one hand, having Z Explore, which used to be Master the Mainframe, which brings new people on the mainframe. On the other hand, with their Champions program having an explicitly mainframe portion, and we see them having on-ramps to it, including with the Z ambassadors for students and such. Then, of course, we all got hit by COVID. And so, just to kind of put this back into cultural and historical context, we see that we all kind of got pushed off of meeting in person and started meeting virtually. And that didn't necessarily work out as well as we wanted, but a lot of things came from that, including Zoom that we're using right now. But there's a question of whether the culture is being depersonalized. As all those various eccentric things we used to do have kind of gone by the wayside. I've got the text for the Share sing along, but there hasn't been a sing along at Share for a long time. All of these interesting cultural things have sort of slipped by the wayside. But the good news is that new cultural things are coming in to take their place. And we'll talk about that on the next slide. But let's just quickly then tip our hat to a couple other really important things that have happened that have helped the mainframe culture and its constituents move forward, beginning with Zoe. It's a wonderful open source, well-supported environment that IBM, Broadcom, Rocket, Phoenix, so many organizations are really getting on board with making it happen so that there is this open source graphical way of interacting with the mainframe that is endorsed and is active. Then we see the absolutely amazing Telum chip that IBM came with that has become the heart of the Z16. And that includes the on-chip AI, the quantum-resistant encryption, and a whole range of different things. And so we see that the technology has not stayed still, but over the past few decades, as the culture has changed, as we've gone through all the various changes in our cultures, we've gone through Y2K and the change of millennium, we've gone through COVID, all these different things have been part of the culture of those of us on the mainframe. And now we get ready for the arrival of the new generation and the fact that they're already here and looking to the future. And so here I'm going to just do a little shout out to Chiara Baldan, who with her husband came up with the idea of a Barbie mainframe, which I think is such a wonderful emblem of the future of the mainframe. And so we see the arrival of the millennials and of new people, digital natives, people who've known computing all their lives, who are completely comfortable. Let's not forget that the people who created the mainframe and the culture of the mainframe were not digital natives. That for them, the mainframe was just another machine they were learning to handle properly. And the whole idea that it was going to change all of humanity was a new idea. Now it has, in so many ways, the mainframe and TCP/IP, commodity computing, all these different things have really come in and changed the world. And so we see the Barbie mainframe after a celebration of the 60th anniversary on the top picture. On the bottom picture, we see Chiara and my co-author and colleague Carl-Eric Stemfors and myself at Tech Exchange in Barcelona with Barbie and her pink mainframe. And so to go consistent with the Barbie mainframes is the Cinderella footprint. And what I mean by the Cinderella footprint is that when IBM came up with the Z16, they made a version of it available that was basically would fit on a single raised floor tile. And so it became compatible with the architecture of data centers, because if the data center wasn't going to include the mainframe, then the mainframe had to include the data center, just like harkening back to USS. When mainframe took on Unix and TCP/IP, now it was taking on the space considerations, having already more than exceeded the energy and other environmental considerations. But as we said at the beginning of the presentation, space, that final frontier. And so now we have the rack mount mainframe, an IBM mainframe that was designed to fit into a standard rack space. And just talking with Tina Tarquinio, she was saying, it's easy to forget that IBM thinks 3 generations ahead on the mainframes. And so what that means is they were getting ready for the rack mount mainframe 2 generations before we saw it. And 1 generation before that was that Z15 with the Cinderella footprint. And so now with Barbie mainframes, we have a world where the future is wide open for us to genuinely party, just in terms of being the party of the first part that continues to run the world economy. And so we take a look at some of the ideas that have been there nascently or sometimes explicitly in the mainframe that have kind of emerged in the distributed world and come back to the mainframe. And so you think about the origin and future of the cloud, that IBM had wanted to do, utility computing right back in the beginning in the 1960s. And of course, unbundling forced them to have to change direction a little bit, and created the whole ecosystem. And yet now with cloud computing, we see that, as T.S. Eliot once said, at the end of our journey, we shall find ourselves back where we began and truly know it for the first time. So we're doing that with the mainframe. We've gone 60 years, 360 degrees, and we're back with all of the principles that really were about manifesting the best of human history in an automated system, because we have not changed the basic rules for things like doing accounting, double entry ledgers, and managing decimal data and character data. All of these things are still key core requirements of the world economy, which the mainframe has handled so well that it's become nearly invisible. And yet, that was always the true aspiration of the cloud. And we use the cloud in some ways to be deliberately nebulous and hide the fact that that's what we were really up to, was just to try to make it so that it was a utility and we didn't have to worry about the details. And the mainframe had us not worrying about the details for decades, so much so people thought it was dead. And for that matter, the people think 3270 is dead. I have friends, including my friend Joe Winchester, who really wishes that he didn't have to use 3270 or SPF, and he was a big fan of Zoe. And great. They're doing wonderful, important, relevant, valid things with non-3270 interfaces. At the same time, 3270 keeps sneaking back in there. You're going to still see a terminal emulator as an option, because there's something about that powerful legacy that is going to still be there on the mainframe today, tomorrow, and when our great grandkids are the ones who are now taking charge of the mainframe, because stuff that works. And that's one of the things about the mainframe, is it invisibly has just kept on working all these years. Now, that said, doesn't change the fact also that we have the arrival of new generations and the slow departure of old generations. I like to joke, that the mainframe is a technology that's been around for so long that it's often operated by a crank. And sometimes I'm one of those cranks. That we have these people who have been on the mainframe for so long that we're often, in our 60s and 70s and even 80s, because the mainframe is a career that won't break you down and destroy you. You can keep working on the mainframe much later if you want to. It doesn't change the fact that we need new people. And so the new mentees who are arriving on the mainframe are not meek, fearful people who are just sort of doing whatever they're told. These are people who are coming in and taking the mainframe by storm. And again, this Barbie mainframe is such a wonderful manifestation of not sitting down and being, spoon fed how we've always done it, but really coming in and bringing all of their ideas and their sensibilities and their inspirations and their personality, and making that part of the present and the future of the mainframe, and at the same time also mentoring the experienced mainframers, so that the experienced mainframers are not only mentors but mentees. Those of us who stick around, I intend to stick around for decades to come, and there's a lot of us who've been around for a while and are going to stick around for a while, and we get to learn from this new generation of the mainframe, as all of the stuff that we've learned on all of the other platforms that have grown up during the past few decades. And the platforms themselves have almost sort of started to go away, but the lessons learned now are being ported to and manifested on the mainframe. And so, although I don't think all of the various non-mainframe platforms are necessarily going away, I think it's important to recognize that what they are doing is they're slowly dissolving into the cloud. And so, we have our mobile devices, and we have the cloud, and we have less and less interest in knowing what's happening underneath. And as that happens, then we have the arrival of a genuine cost benefits evaluation. And the mainframe always wins that at a certain scale and above. And so the original wheel, the 360-degree wheel, rolls into the future And just like the wheel that was invented, time immemorial in the past, wherever it's rolled in, it's changed everything. So it came to North America, to the Americas, 500 years ago, and changed everything. Over and over again, we see that the wheel has become foundational as we build on and elaborate it. So likewise, that 360-degree mainframe rolling into the future moves us from the space age when it was first invented to a true future of humanity, where it is one of the things we, in the very best way, take for granted. But those of us who work on it don't merely get to take for granted, we get to be involved in its continuing to move forward with us, for us, with humanity. So, all of that said, I hope I've left room for a lot of discussion about all of this. And so I'm going to open the floor. And first, Herb, any questions that have shown up during the conversation?
Hello, Reg. So, and let me just scroll to see if there's anything further down there. No, everyone was listening attentively. Um, but there's one or two things that I might ask to
Please.
kind of kick things off. So, fascinating kind of take on it all. One thing I was wondering, and oh snap, we've got those same jackets there. Uh,
Oh, yeah.
have you ever read Rudolph Weinstock's The Eternal Mainframe essay? And what were your
I do
thoughts
not
on it?
believe I have. If you have a
Okay,
link to it, I encourage you to send it to me. Thank
I,
you.
I will pass it along because very much what you were saying about at a certain scale, it's the model that makes sense, and that's why we have cloud now because we've
Mm.
kind of reverted to that mean kind of
Hmm.
thing. Um, I mean, in a way, I kind of have a couple of observations. You mentioned um, about because some platforms kind of dissolving into the cloud, and I'm thinking some of the competitor platforms that we would have seen. I'm thinking particularly kind of VMS. I remember being kind of someone trying to draw me into Open VMS at one point, and maybe it's not so much that they're dissolving. Maybe it's more that the mainframe is the only platform that's lived long enough to have multiple generations on it. And while various things have kind of come and gone, perhaps now as the first platform to have kind of multiple generations kind of hand things on, it may kind of form a model for other platforms for how they can have longevity. I don't know if you've any kind of thoughts around that, or noticed some of the things that happen when you are passing artifacts between generations.
Mm. I'm thinking of a bunch of different answers I want to give you, and I'm going to go with Dante. Um, so now, if you're a Dan Brown fan, you're probably familiar with Dante Alighieri and his Divine Comedy, which he talks about, hell and then purgatory and then heaven. And as you may know, Multics,
Mm.
one of the great major operating systems, was a project that was intended, among other things, to have security embedded into it, and military grade security, where it had rings of security, so the people in the innermost ring could see everything, and the people in the outermost ring, everybody could see their stuff. They couldn't see anything. And so, in order to do this, this was at a time when there wasn't the language yet for talking about this. And so, people are concerned that they're going to have a Tower of Babel kind of effect where each person used different words for the same thing. And so, in order to avoid that, they tried to identify something in classical literature that had multiple rings, and they came upon Dante's El. Or Inferno, perhaps to be a little more pleasant. And so we see the Multics being designed and built using the language of Dante's Inferno because it had the multiple rings. And so whenever they had to innovate something new, they would then reach out to Dante's Inferno and say, what is it called? And so one of the things they discovered is they needed, operating system processes that could move back and forth between the various rings. And they said, okay, so in Dante's Inferno, who could move back and forth between the rings? The correct answer is Dante and Virgil, because they were doing that. They were touring it, but of course, they're not actually part of the system. But who was part of the system? Well, the daemons. Now, you could say demons because it's hell, but demons is a nastier word. And we have this whole eudaimonia, the idea that daemon's just a spirit. So fine. In order to be polite, they said we'll call them daemons instead of demons, but that they're going to be moving back and forth. Well, Multics, of course, is now sort of the footnote in history. But what we don't realize is that the generations of Multics have taken over the world because a couple of the guys who worked on Multics got a hold of a DEC PDP and wanted to write computer games on it, but they didn't want to have to rewrite the hardware drivers every time. So they took everything they learned from writing Multics and wrote their own one thing at a time. So Multics, many things. This is one thing at a time, and it was meant to be not very potent, hence the pun on the word eunuch. They called it Unix. And so the idea was that this very light operating system would give them the ability to not have to rewrite the hardware drivers every time they wrote a new game program. And that was all it was ever intended to be. But as they wrote it, they felt compelled to live up to the standards of a real operating system because they'd learned them. And so one of the things that they did is they introduced daemons, as that's what they call their operating system process. Now, as you get to know Unix, you notice there's a whole bunch of other sardonic references to established literature and religion and such. If you give yourself read write access to a file on Unix, you get a little bit of an interesting implication there. And so there's this whole weird culture, sardonic kind of culture that refers indirectly to, among other things, the contents of Dante's Inferno, and that was a generational inheritance from Multics into Unix, which is now pervasive, including in Linux. And so we see that. And what's really interesting is this goes all the way back to pre-computing history, just like the mainframe and XML and Aquinas. And so that all of human history has found its way into computing, and computing has found its way into history. And so we see the generations then continue to pass this stuff along. And it's not quite as curious as an appendix of where the heck that came from and what we have, but it has that similar secondary reason for being there that it doesn't exactly justify it, but it explains it, and it's there. And so on the one hand, we have a culture in the mainframe that is very much what I like to call East Coast computing. That it's about the business parts of North America, and it's all about business and obviously the business districts in London and all the business across the Atlantic. I guess you could call it Atlantic computing. Then you've got the Pacific computing, of Unix, of Windows, of Apple, of all these things that really are almost about filling the gaps left behind by the Atlantic computing. And so we see the generations, including the sardonic attitude to the powers that be, the do not fold, spindle, or mutilate attitude, all of those things. And so as we see that we've got all of human history implicit in this and the inheritance between generations. And so on the one hand, as these various platforms then move into nearly archived status, we see, among other things, that Unisys, which used to be UNIVAC, became basically an emulated environment on Intel. Likewise, with the VMS, OpenVMS now is running on a commodity consumer chip and not on its original DEC architecture. And so all of these various operating systems that were sort of also RANs, these platforms that are also RANs, kept their relevance partly because they found a way to emulate them into a more long-term existence. And so they are able to continue to have a relevant, valid functionality because we lifted them and shifted them and dropped them onto a more generic, almost proto cloud-like platform that meant just running everything, on Intel and potentially under something like VM or VMware or some other hypervisor. So I don't know, what are your additional thoughts on that? Because I guess you've got some thoughts on that too.
Yeah, I mean that's a wonderful direction to take it in. I mean, I really do like the notion of Atlantic versus Pacific computing, and yeah, the references in Unix to yeah, daemons and all the rest of it is kind of you think people are making them up, but actually, it has that kind of a history. I mean, I just want to check that it's not me monopolizing. I'm looking at the chat. If anyone else had another question, just so I don't go off into it and start enjoying myself.
And feel free to email us after the fact as well if you're watching this on replay. Herb, where can people reach you these days?
So use my GSE address, herbert.daly@gse.org.uk. That will find me at one of my addresses that kind of makes sense. I am going to post. I just found it. that eternal mainframe essay,
Good.
which
Thank you.
I think might be uh, might be an interesting take on kind of the longevity of the model.
And for
I
people
mean,
who want to reach me directly, I'm the only Reg Harbeck on the internet, reg.harbeck, or reg@harbeck.ca for my Canadian email address.
so I was going to ask, have you a particularly skills oriented take on this whole adventure? You know how so you mentioned there with the phonetic alphabet. I just wondered, are there other kind of skills lessons that we could take? Is there something that, you know, if I was advising, and this stream, we often kind of see it as kind of we seesaw between the type of things we'd want hiring managers to think about, perhaps newcomers on the platform to think about, and kind of that conduit between the two, potentially trainers to think about. Have you any advice for those groups potentially?
So the first thing I will say is I absolutely endorse your choice of the word skills, because one of the things about skills is you don't actually learn skills in a classroom.
Yeah.
You learn skills like this, not like this. You know,
Mm,
and this is one of the key differentiators between practical computing and theoretical computing. So you go to university and you learn theoretical computing, you learn about history and theory and all these things. But you know, even with your late night programming assignments where you hand in your program at 6 a.m. the day it's due, kind of thing, you know, which is a bit of skill development. Really, the actual practical skills are stuff you either learn on the job or in interaction with the job, where you can make that visceral connection with why am I doing this? You know, and so although I'd be the first to be a proponent of getting one or more university degrees, at the same time, I recognize that to learn mainframe, no matter how much you learn in course in university, that the stuff you learn on the job is a differentiator until you're being apprenticed and mentored into the space. And so on the one hand, we've got all these wonderful things like the Z Ambassador program where you can do pre-job apprenticeship, and mentoring, and that's really important. But that really comes down to, until you have a legitimate practical reason for using these abilities, they don't take root in your personality. And so you can learn all the theory you want, but until the rubber hits the road, and you have to know this because the system is crashing around your ears, and you don't want to have to IPL on a Monday afternoon. You're not going to have that stuff embed itself into your worldview and your approach to everything. And so what you're doing with your education in many ways is you're setting up the the context, the platform, if you will, in your own experience and foundation, to be ready to receive those skills when they have a relevance to you, because you need them to get a result. And so for me, what you're learning as you learn the academic stuff, as you do the assignments, as you do the various mentoring, all that stuff, you're setting the groundwork. But it's only when you actually are in a job, whether it's an apprenticeship type job, or one of these other things, or actually there's, as a systems person, learning it as you go. That's when all this stuff can take root in your consciousness, and then you can finally start asking those questions and understanding the answers and having it all work together. And I've often said that if computing ever becomes a real profession, that learning stuff the way we do it on the mainframe is going to be a required part of forming properly as a professional, because the whole mainframe ecosystem is based in human history, is about doing it properly, and doing it in a manner that respects the importance of what you're doing. So, what do you think?
I'd very much agree, and I think that's probably a pertinent place for us to stop, as we've just about come to time. Reg Harbeck, thank you so much. I'll use the recording of this talk to seed some conversations with groups I'm meeting up with, and I hope we can have you back again sometime in the stream, and talk about some of the things that you've been up to yet again. Anyway, so thank you very much, everyone who joined us. I'd urge you to go now to the feedback link, So you can follow the details that you see there, or you can, if you go to the Bring Your Own Agenda, there'll be a link that you can click on, and it will automatically populate your feedback. So thank you very much indeed, Reg. Look forward to hearing from you again, and
Yes.
everyone else, look forward to seeing you at future sessions. Thank you so much.
Thank you.